right, so we'll continue with our review here in a second. But before we do that, Corn Hacks is an annual hackathon event that we have somebody here to recruit for. It takes place in the spring. I believe that they've got the schedule up already, right?
Yeah.
All right. So if you go to unlcornhacks.com, you'll have more information. But here to tell you more about it, I'll go ahead and hand it over here.
Yeah, he got a lot of it already. I was just going to say, Corn Hacks is a hackathon during the spring in February 17th and 18th. So a little ways out, but we're trying to start early. Maybe the schedule's not out yet, but yeah. So basically, how it works is you can either be on a team by yourself or up to 4 people, and it's just 24 hours. You get to make whatever project you want. Our theme for this year is beat the odds because we can't legally say gambling, but it's kind of like in that realm a little bit. You don't have to follow the theme if you don't want. That's just kind of a suggestion. You can follow. There'll be judges to judge. They're usually from businesses in the community. A lot of the businesses in the community also give a lot of funding to this. So if you go, there's free food. It's free to apply. I should mention that. It's a big thing. Free to apply, or free to join. Free food. And then there's up to $3,000 in prizes. So if you're one of the top teams, I mean, usually we send a lot of people home with prizes, but top teams get stuff like iPads and stuff. So it's a good thing to be part of. If you need any more information, you can just look up UNL Corn Hacks. You'll find us. But yeah, thank you guys.
Yeah, and it's been going on now for I don't know how many.
I don't even know.
I want to say at least 5-6 years, at least. But I highly recommend it, even though you're a freshman, even though you've only gotten one course under your belt already. You can still do a lot, right? And it's an opportunity, even if you don't go there to intending to win or anything like that. It's still an opportunity to learn something and build something. For example, now that you know Java, maybe you just want to learn App Builder so that you can build an Android WYSIWYG app or something like that, right? Awesome. Or Unity for game development or something. Just build a really quick 2D game or Godot or whatever, right? It's plenty of food, plenty of fun. 24 hours, so you'll stay overnight. You don't have to if you don't want to, of course, right?
Yeah, right. I don't think many people do.
Oh, okay.
It's an option. There are people who camp.
All right.
All right.
Thanks.
You.
So to continue with our review, I thought I did Advent of Code Day 3 over the weekend, and I don't know what it is this year, but they're way harder than they usually are in the first few days. But anyway, I decided to switch gears here, at least for today, and go back to the final exam from fall 2022, 1 year ago. Now it says part 2 here because we did like a survey as part 1 that year. We're not doing that this year. Partial credit is possible because you are producing a series of reports, and if if report 1, 2, and 3 all work, and then report 4 seg faults out, preventing all of the others from running, what you want to do is, and you can't get it to work within by the due date, take it out so that at least you get partial credit for those other reports. You'll have the same directions for your final exam on Tuesday, 1 week from tomorrow, by the way. So here's the problem statement. We have 2 weather stations that periodically take temperature samples, and each point consists of a date time stamp in an ISO 8601 format. So that means year, month, day, and then a time, and then on a 24-hour clock here, and a temperature in Fahrenheit 76.2, right? Data from the 2 weather stations is stored in 2 different files with the following format. We'll just take a look here. On the first line, it tells you how many data samples there are, 1, 2, 3, 4, 5. And then you have the date time stamp followed by a space, and then the actual temperature sample here, right? It's all made up, so wildly different temperatures here going back and forth. And it's not necessarily in any order either, right? It's just all made up. The final exam is when, everyone? Did I say Tuesday, right? Did I say Tuesday? Okay, good. Yeah, it's next Tuesday. You'll have a 24-hour window, so all of Tuesday. It'll open up 1 minute after midnight in the morning on Tuesday, and then it'll close 1 minute before midnight on Tuesday. We've already provided some starter code here, right? Will we have a full day? Yes, we will. It'll be your task to code several reports. So the first report here is going to look something like this. You're just going to go through and find what was the minimum temperature, what was the maximum temperature, what was the mean temperature, right? That's pretty straightforward, which is why it's only worth 20 points here. And then we're going to do some data reports here. So for the data in data set A, report the earliest available by date, and then the most recent, so the latest. And it should look something like this. Right? Then there's another report for inconsistent or missing data. So the two weather stations are taking samples independently. They could disagree. We want to know when they disagree. Or one of them could fail, and the other one could have taken the sample, and the other one didn't have a sample for that date and time. And we want to know when this one has a sample, but this one doesn't, and then vice versa. This one has a sample, but this one doesn't. Right? So your output should look like something like this. There's inconsistent data. On this date timestamp in the first data set, it was recorded as 32.78. In the second one, it was recorded as 32.90. Not that big of a deal, but we want to know when it diverges like that. The missing data here is in data set A has this, but data set B doesn't. Right? We can be more verbose about that if we want to. It was in A, but not in B, or it was in B, but not in A. Okay. Now, the samples that we provided were very, very small. They were only 5 samples here. But we warned in the handout, you will have millions of samples, right? So any way of doing this naively is probably not going to work, right? Iterating through, like for example, for each element over here in the data set A, you search for it using linear search over here. If you do that and you have a million over here and a million over here, a million times a million, that ain't executing in 5 minutes, right? A million times a million, we call those a trillion, right? Trillion operations, and you're doing it over and over and over again, okay? So we're gonna have to be smart about it. We've got some starter code here that we'll go ahead and do the Java version first if you want to, or Java or C version. Which first? Java, okay. Because I'll probably do the C version in the afternoon anyway if you want to watch the live stream there instead. I'm gonna go ahead and cut and paste, nope, come on. There we go. And copy that. Yes, copy that file. And there's weather data. Uh-oh, looks like we put it in CSE instead, SOC. We'll go ahead and change that. All right? So let's just watch, let's see what was provided first. Right? Weather data is a 2-tuple, right? It has a date timestamp, which we're treating as a string. So we're not going to get fancy and use a local date time, although you could if you wanted to. And we've got a double, which is a temperature here. We have a constructor that takes both of those things. And by the way, let's go back over here really quick and discuss why did we use the ISO 8601 standard? In fact, why is the ISO 8601 standard the only correct standard? Americans, we put, month, day, year. Europeans will go day, month, year. Both of those are wrong. Why? Because they are not lexicographically orderable, right? If you want 2017 versus 2016, all you have to do is compare them as strings, and 2016 comes first. Then by putting the month next, earlier months come before later months, making sure that you always have a leading 0 if necessary. And then by day, and then by time. Making sure that you have leading 0s everywhere to ensure that all you have to do is string comparisons in order to put this date that came first after or before this date that comes next, or reverse it if you want to. So by using that formatting here, we don't have to get fancy with local date time. We can just use strings. Here's a constructor that orders weather data objects by their temperature in increasing order. Right? We have to implement it. Hint, you probably want to use that. Why do you want to use by temperature? What was the first report that we had to run? Find the minimum. If I ordered it by temperature, where would the minimum be? At the very top. Where would the maximum be? At the very bottom. What would the mean be? You'd still have to run through it all, add them all up, and take an average. Okay? Mean, not median. All right, by date. All right, why would you want by date? Well, what's the second report? You want the earliest, you want the most recent. Guess what you do? You sort it. right? And once again, it's going to be one is going to be at the top, the other is going to be at the bottom, right? So strong hints here on what to do, searching and sorting. We also gave you complete code here to load it from the file, right? So you didn't have to do that. If we didn't give you this code, it should be just pretty straightforward. Go back to hack 10, pull out that code that loads up every single line in a file, ignore the first line, and then process every line after that. That's what we're doing right here, right? I'm reading in the first line. In fact, where is it? Files.read all lines. Right? Oh, oops, sorry, that's part of the files class there, right? In fact, if you need to do hack 10 over again, right? Those lines should have only been like 2 or 3 lines in each one of those methods. The file IO, right? Why? Because you can, of course, call this thing over here, files.readAllLines. And no, there's not something like that in C. Right? We load up all the lines. We remove the first one because we want to treat it as n here. And then we go through all the rest of them, split it along spaces, and then create a new weather data here based on the first token, which is the date timestamp, and the second token, which we parse into a double for the temperature. Then we add it to the data and return the data. Here's the main. We're going to read in the first file and we're going to read in the second file, and we're going to load up the data set A and data set B. Right? Data set A, excuse me, there we go, and data set B there. Right? And then we just print out that we loaded up certain numbers of those. So let's go ahead and make sure that this is actually loading up the data first. And to do that, we're going to have to make sure that it compiles. So let's implement these two things right away here. Right? You tell me, how do I order it by temperature? I'm comparing weather data A and weather data B, which have only 2 pieces of data, date timestamp and temperature. So how would I compare those two things? A dot, by temperature, it's going to be temperature versus B dot temperature. Now, should I do the difference trick here? There's the difference trick. All right. Well, first of all, Java is not even going to allow me to do this. Why? What is the return type on this comparator? An integer. What is the difference between 2 doubles? Is that an integer? Nope. So it's already warning me that I'm doing something wrong. All right. So what do? I just write, the straightforward thing to do would be to if A is less than temperature of B, then what? Return something negative. Else if A dot temperature is greater than B dot temperature, then return something positive. Otherwise, what's the only other possibility? Return 0, right? Now let's make sure that this is correct in increasing order, non-decreasing order, right? So if this is less, then this is greater, then they're in order. Is that increasing? Yeah, looks like it to me. If not, we can fix it. Okay. What about by date here? Oh, by the way, what else here? You could have done something like this instead. No, I don't want to go that far. How could I get this down even further? Oh, okay. Yeah. Math.signum, or sign of the number. Then you can use the difference trick, right? A dot temperature minus B dot temperature. What that's going to do is it's going to return something negative, positive, or 0, depending on the sign of this difference right here. And you can return that, but unfortunately you do have to explicitly typecast that because it still returns a double. Right? So there's another way. How could I get this down even further? I could use that more modern syntax of comparator.comparing weather data get what temperature? There. Oh, do we not have a getter here? Oh, we don't. That's okay. So type, make a getter. No. Source, generate getters and setters. And for these, I'm just going to have these two as getters. Getters, right? Yeah, there we go. Generate. There we go. And now it compiles. Got it down even further. All right. And by the way, the natural ordering is in increasing order. So this comparator will compare the temperature, the doubles, in increasing order. If you wanted to, you could, of course, reverse that. Reversed. Way too fancy. All right. What about this one? We'll go ahead and use the old school way here. If A dot temperature is less than B dot temperature, can I do that? Or sorry, temperature, not temperature, what is it, by date? So it's going to be what? A dot date and date timestamp, and then B dot date timestamp. Why? Because those are strings. Can you use less than, greater than, or equal to on either language with strings? No. Luckily, they're already comparable. A dot temperature dot compare to B dot temperature. And you just need to return that. Again, that's a trick because it is lexicographically ordered. If you want to go back and refactor this, I mean, you could change this so that it wasn't a string. Instead, it was a proper private final date, local date time, right? Something like that instead. And then this is still orderable. They've already written the code to order this for you in increasing order according to temporal order, right? So past, future, past to the future, right? I wanted to keep it simple though, right? Oh, what's wrong? Oh, temperature. God damn it. Date time stamp, was it? Compare to, there we go. All right, good. What's another way that I could have, oh, by the way, I'm using this because I'm only in this class. These are private, but what can see private variables? The class itself. So even though I'm in the class here, I can still see A's date timestamp. It would be better to use the getter now that I have it. I didn't have that before. There we go. All right, I'll leave it like that. Now this actually runs. Let's go ahead, or now that this actually compiles, let's go ahead and run it. Of course, I'm not providing the first name or the two file names here. So let's go ahead and bring those in now. I'll put them into data. We provided input sample A and input sample B here. Cut, paste those. There we go. Copy those files. And now data input sample A, input sample B. I need to put those as command line arguments. In the data directory, what was it? Input sample A.txt data slash input sample B.txt. Apply that and run it. Question on here. How does it know to look for lexicographic order for strings? That's just built into the language, right? So for example, let me go ahead and look at the string class here, right? The string class is comparable. That means it's got this compare method. Compare to, there we go. And where is it? Find, compare to, all right, fine. Public int compare to, right? There it is. So all that logic was already written for us by the Java folks 25 years ago, right? That's how it knows. All right, so what we have, all right, it successfully loaded everything up. If you want to, you can print them out. I don't want to. I want to generate reports. That first report is going to look something like this, right? This. And for that, I'm just going to steal that ASCII right there, right? So system.out.println, there we go. Temperature reports, data set A. Go ahead and get rid of that end line. There we go. And then system.out.println. You can make it look as pretty as you want. I don't care. For this year, though, you are going to have to follow some really strict formatting because that's how code post works. Last year we were using a different grader where we were manually looking at it to make sure that all the numbers matched. All right. So system.out.println minimum, actually printf here, minimum. It's going to be %f and the line. And then we'll need a value there. I'll do that for the mean and the max. Make sure everything lines up and looks nice and pretty. White space will generally not matter. There we go. All right. So how do I go about getting those values? Well, first of all, we need to declare them, right? So double, min, max, mean. Right? How do I find the minimum temperature value? Again, if I sort it, where was it going to be? The very top. So collections.sort, I'm going to sort data set A using my comparator for, what did I call it? By temperature. There we go. And now all I need to do to get the minimum is get that first element. Data set A dot get the first element, which is at index 0, dot get temperature. There we go. What about the max? Do I have to resort it? No, right? The max will be where? I really wish there was like a dot get last or something like that, or last, but nah. What do you have to do? You have to ask how big it is. So data set A dot size. Okay, dot get temperature. Careful, it's 0 indexed. If there were 5 things in there, 0, 1, 2, 3, 4. So what do I need to do? -1. That's the max. So min, max. What about the mean? Here. I think we can actually run it now. Oh, it hasn't been initialized here. So mean is equal to mean of data set A, right? If you were doing something like Python and this was just straight up numbers, you could do something like that. But no, what do I have to do instead? I have to compute the mean. So you can go ahead and write a function to do that. I'll just go ahead and do it in line here. Int sum, right? Or int double sum, right, is equal to 0.0. Initialize your variables, even though in Java it would be initialized to 0 automatically. Now I'm going to use an enhanced for loop to iterate over every single temperature value. So for weather data, WD, in data set A, I will say sum plus equals WD dot get temperature. After all that's just been said and done, mean is going to be the sum divided by data set A dot size. Do I need to worry about integer truncation right there? Sum is what type? Double. The size is an integer, but at least one of these is a double, so we're good. Run this. There we go. Are those the correct values? Well, it's small enough that you'd have to look at it. So there's data sample A. What's the minimum? That's certainly the minimum. What's the maximum? That certainly is. Take out your calculator and go dot, 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 and see if the mean is correct. I assume it is. All right, that was simple enough. What about the most recent and the oldest? The earliest and the most recent for data set A here. All right, so once again, I will use system.out.println for those first two. Get it looking nice and pretty. Oops, come on. And there we go. And then printf earliest. And then I'll put in a question mark here because it looks like we want to print out both the temperature and the date there, right? And then system.out.println, printf, excuse me, the most recent. And once again, I'll put in question mark, because I don't know how to do that yet. It looks like there's no colon, who cares? All right, well, same trick as I did up here. I will go collections.sort, data set A, by date. Now the earliest is going to be at the first one, so if I want to print that out, then I can put it in here. Earliest is going to be data set A dot get the ith element 0. In fact, I already wrote it up here. Let's do it same over here. Now I want to print this out as a string. Now I remember that it wanted both the date and the temperature. Is that going to get me this? Let's find out. Nope. Well, first of all, I need to put end-line characters there, right? Make it look nicer. There we go. But is it giving me that nicely formatted value there? No. What do I need to do if I want it to print out in a certain way in Java? How do I get it to print out a class? The toString method. Generate the toString method. It's not going to look that pretty. It's not going to look exactly like the handout says over here, where it's like out to 3 decimal places and then parentheses and then the date time. But we can do that. String.format. String.format is exactly like printf or sprintf. Right? And so what I'll do is %f and then in parentheses %s. And I will print out this date timestamp and temperature. Oh, I guess it's out of order, right? Temperature first and then date timestamp. There. Now once I've overridden that and defined that, then it's all automatic. Right? Was that in fact the earliest? 2017, 2022? Looks like it to me. I made sure that they were all different years. Simple enough so far, right? Now comes the big one, the one that's worth, that was why it's only worth 15 points and 20 points, right? 40 points here. We need to find inconsistencies. We need to find, for each element over here, we need to find the one, that data point in the second data set. If we don't find it, then it's missing. If we do find it, then we need to check, are those temperatures the same? Okay? So, help me out. A data point is identified how? By the date, right? The only thing that can differ is the temperature. So let me, we've already sorted it by date here. So let's go ahead and say for each element or for each data point in data set A, right? Let's outline this. Find the data point according to the date in data set B, right? 1, if no such data point, report missing. Else, if temperatures are not the same, if temp A is not the same thing as temp B, then report inconsistency, right? Else, do nothing, right? Nope, that data is clean. All right, how do we translate that first line? For each data point in data set A. We've already done that actually, right? This nice enhanced for loop up here, okay? Find the data point date, by date, right? I should say by date, in data set B. Now remember, 1 million, 5 doesn't matter. But 1 million, or say 10 million, and 10 million over here, that's 100 trillion operations. That ain't gonna happen, right? So how do I go about searching for it in data set B? Quick binary search, right? And we have collections.binary search. Right? And I want to be searching data set B for what? For data point WD. Right? Using, careful, by date. That will return, what does it return, by the way? An index, right? Searches is specified, blah, 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 and the list, and it's going to end up returning, here's the return type, returns the index of the search key. If it's contained, otherwise it returns what? Something negative, something negative. Now, the magnitude of that gives you a hint as to where it should be if it had existed, but it's not necessarily -1 all the time. So let's go ahead and capture that index value. Okay? Before I go on, wait a second. Binary search. If you're going to be binary searching a data set using a comparator, then what does it have to be? It has to be sorted. I sorted data set A. Did I ever sort data set B? Nope. So let's go back and do that before we see why it doesn't work. Data set B by date. Now they're both sorted. Now, here's another trick that you could have used, right? Sort this one, sort this one. Now they should be in the same order, right? So just go have two pointers or two index values here. Oh, those two match. Those two match. Those two match. Oh, those two have different temperature values. So report that. Oh, wait, now I'm going down to the next one. Oh, this one doesn't match by date, right? So that means that this one is missing from this data set. But what are you going to end up having to do with your little pointers now? You advance this one, but you need to make sure to stay on this one so that you can you can find it later on from over here. In other words, they're going to go out of sync real quick if there's missing data, right? And I don't want to have to think about that, right? I mean, that you can do it. It's just going to be way more complicated than what we're doing right here. Just use binary search. Right? Okay. If no such data point, in other words, how do I know if there's no such data point? If index is less than 0, then report it missing. What did it look like? Missing data. System.out.printf, missing data. And because I went back and wrote that toString method, I don't have to do anything else. I'm missing WD. All right? There we go. Else if, right? Now I do have values, right? I've got a value here at index, and I've got WD here. Else if WD dot temperature is not equal to what would it be? Data set B dot get index dot temperature. If those two are not the same, then report it system.out.printf, and it should be inconsistent data. Now here I'm not going to be able to use that magic string thing, %2.2f. There we go. %.2f, %.2f, right? And then there's the date, so %s. How do I go about formatting this? Well, it's going to be the first one, wd.temperature, and that's not equal to this thing right here. And then they have the same date, otherwise it wouldn't have matched, so wd.datetime. There. Inconsistent data. Be careful, right? As you've seen, equals strict equality and strict inequality with floating point numbers can be very, very error prone. Once again, take an example of 1 divided by 3. That gives you 0.333333, but at the end of the day, down here, what? 4 or 2, right? You multiply that by 3, you don't get 1 back necessarily, right? So I don't want to have to worry about those problems. Instead, what I'm going to do, I'm going to take the difference. Now, if the absolute value, math.abs, of the difference there is greater than, I don't know, 0.01, then report it. Then we're really off. In fact, I think that's in the handout, but I don't want to go back to it right now. Otherwise, do nothing. All right. And my for loop there. Okay, we're still not done yet. There we go. Earliest inconsistent data. Ooh, and then missing data. Oops, I need N. Right. There we go. I think I also provided the expected output for this small one, and we are indeed matching that. Those two are off. If you look at data set A, then it's 0.197. Over here, it's really clear. You go back and forth, right? Do you see the differences there? small enough that you can see the differences, and then we've got this missing data here. In fact, do we have 2021 over here? No, but it's not being reported. 2021 is not missing. What did I do here? For each point in data set A, check to see if it's in data set B. Did I look at anything in data set B, the second one, and check to see if it's also in A? Nope. So we need to repeat this. Right? We don't need to repeat the inconsistency because that would have been found A to B, B to A. We just be doing double duty and reporting everything again. So instead of going over data set A, I'm going to go over data set B. Get rid of the cruft. Right? I'm going to binary search data set A. Right? And then report that that's missing from data set B. Right? Or data set A, excuse me. There we go. 2021 is now showing up. Right? This is almost perfect. I'll go back and clean it up. Right? Maybe reformat it. There we go. Done. Take out the cruft and turn it in. Right? We only have 15 minutes left, but do we think that we could do the rest in Java? Let's see. Or Java. We just did it in Java. We could do it in weather reports. There we go. Oh, and probably want the data there too. By the time it loads up, we won't have time to do it. There should not be too many size restrictions or file format restrictions. We're going to give you files that are, say, tens of megabytes, right? And you can go ahead and drag and drop those over here. Let's just go ahead and create a new folder, final review. It's not the actual final, but you can drag and drop stuff up there. There we go. Now let's just take a look, because we'll continue it next time. Let's just take a look at what we were given. Right? Almost exactly the same. Right? We're given a structure for data time, for weather data. The date time stamp here is hard-coded to 17. Why? Because it's an ISO 8601 standard. There are always 16 characters in it, regardless of the date, regardless of the time. Right? That's another benefit. There's 16. Why did I do it at 17 then? Null terminating character. And there's our temperature. We give you the load from data file functionality. We give you the strong hints that you should be implementing these comparators. We give all that code to you to load it up. The only thing we don't give you is the comparators, because that's kind of what we're testing here. All right, so we can at least write these comparators. What's the first step in doing a comparator? Cast it. Const weather data star x is equal to casting of A. And then y is going to be a casting of B. There we go. By date, again, it's a string. So all you need to do is use string comparison. Return strcmp of x date time, oh, what was it called? Date time stamp, and y date time stamp. Right. Copy, paste. There you go. Oh, sorry, what? Uh-oh, you're right. That's why we don't copy paste. All right. Here I don't have a signum. That's not in the standard math library. Signum, remember that thing would look at the input, right, and it'll give you -1, +1, or 0, depending on the sign of this thing right here. Right? So instead, we do have to write full if statements. If x's temperature is less than y's temperature, right, there we go. I always have to sound things out to get it spelled right. At least I'm doing that in my head, even if I'm not speaking. So I don't know if other people do that or not, but return -1. Right? Else if, same thing here, but swap the sign. Right? Alternatively, you could have swapped x and y. Return 1, else return 0. Right? There. We did not give you all the apparatus over here to print it out, convert it to a string. We didn't give you like an init function because we do that for you over here, right? We're creating weather data, and then we're initializing this for you, right? It's not that big of a deal, so we didn't have to use an init. There's only two things, right? What do weather reports look like? Well, we give you some data there as well, right? We load up the data from the first command line argument. We load up the data from the second command line argument. Remember that these are arrays, so we're also going to have to keep track of the size of each one of them. And if you're missing data in one of them and that you don't have in the other, they're not necessarily the same size, right? N and M here are not necessarily the same. So even if they're the same size, you could be missing one data point over here and one data point over here, and they end up being the same size, 5 and 5, like in the example. But one is missing from one and one is missing from the other. So keep track of all that stuff. Even give you free so that you're not misled by running Valgrind when you need to. Right? Generate reports. Here, question. What is comparative looking at with the comparing function to see how order should be determined? Good question. So let's go back over here before we continue here. Where's my comparator that I created with the fancy syntax here? All right, so let's walk through this again. Compare.comparing. This is what's called a function selector operator. So what it does is it generates code that calls the get temperature function on one, get temperature function on the other, and then does an if else condition. Right? It's just a syntactic sugar so that you don't have to write it yourself, right? Like I just did over here in C. Right, right there. Right? It generates this basically, but it calls getters automatically. Right? All right, I think that we can do at least one of the reports, min and max. How do I go about sorting in C instead? Q sort. And what are you sorting? Data set A, or set A. Right? And what are the arguments to it? The number of things in it, n. Remember that n is the number of things in it. And you are also needing to tell it how big each thing is, weather, data. Right? And then finally, the comparator that you want to use. Well, if you're sorting it by temperature, then you'll want to use that one. Right? Now the min, or double min, is going to be where? At data set A of 0, the first one, dot temperature. Right? The max is going to be at data set B, or A, excuse me, of n minus 1. Remember, n is the number of elements in it, dot temperature. Right? And then the min, or the mean, double mean, right, equals 0.0. How do I go about doing that? Well, it's just a traditional for loop. For int I equals 0, I is less than n, I plus plus. Right? I need a total, sum, right? And sum plus equals data set A sub I dot temperature. Right? And then double mean is going to be sum divided by n. Once again, do we have integer truncation problem there? No, because we use this double for sum. We can come over here and steal all this code and then translate it. Actually, no. I don't want to have to translate it all. I'll just grab the stuff that's relevant to me. There we go. Call a style at that point because I don't want to, not print ln, but print f, and the line, tab over. I don't even want to do that. Is that all good? cdc, h, final, tcc weather, .c, and weather reports. Good. A dot out on input sample A, input sample B. There we go. It's exactly as before. Right? I don't want to have to tab over. I don't want to have to tab over. Remind me, in Eclipse, how did I get everything to look pretty? Shift Command F, right? If it was all over the place or something like that, right? Shift Command F, we'll fix it. What about over here? A style, weather report, .c. Close it, reopen it. Ah, nice. All right, we'll go ahead and pick it up there next time. But basically you're just translating. All you're gonna do is what? Do another Q sort, take the first and the last. You're going to do another Q sort and then a for loop. But instead of binary search, you're gonna use B search. B search does not return an index. What does B search return? Pointer, exactly. Right? And so we're gonna have to do that next time instead. Just one other quick review here. Why did I use arrows here? Because they're pointers. Why did I use the dot operator here? Because it's a regular old structure. This is an array of structures, which is a pointer. But indexing it gives me one of those elements, and one of those elements is just a regular old structure. So you would end up using the dot operator. Right? All right, next time.